So right now we are going to work on solving systems of equations by elimination. All right. Again, systems of equations are just when you need to, you are solving um, for a set of two or more equations. All right. And you want to find a solution that works in both of those or more, however many equations you have. Right. And so you're going to have two or more variables, all right, when you're solving your systems of equations. Okay, now with the elimination method, right, we want to eliminate a variable. So get rid of a variable, okay, when you're adding or subtracting your two equations, right? So we want to get rid of a variable, okay? And we do that by getting the coefficients to be negatives of each other. Okay, so you might not be understanding that exact explanation. So let me just start with a nice simple equation. Okay, so we have negative 4x plus y equals 6. And we have negative 5y minus y equals 21. Okay, so what did I mean by the coefficients? I want them to be negatives of each other. And so you can see here, right? So this negative 4x and this negative 5x. I'm not looking at those guys. I'm looking here at my y's because both of those y's have 1 as their coefficient, but one is a positive 1 and one is a negative 1, right? This is plus y and minus y. If I were to add these two together, I would eliminate the y's, right? So that's why it's called your elimination method, okay? So, and that's all I'm going to do. I'm going to add these two equations, and I'm going to create a new equation with only, that's going to have eliminated one variable. So I'm only going to be left with one other variable to solve for. So negative 4x plus a negative 5x is going to give me a negative 9x. Positive y plus a negative y is 0y. So we don't write that. Those have been eliminated, okay? Is equal to 6 plus 21 is 27. And now I'm just going to solve for x, right? So I divide by 9 on both sides, right, to get rid of that coefficient in front of your x. And so I get that x equals negative 3. 27 divided by a negative 9 is negative 3. Okay, so that's my first variable. X equals negative 3. But now we have to solve for the y variable, right? So we're going to take that x equals negative 3 and put it into either equation that you started with. I'm just going to use the top one because it's the top and I might as well. So negative 4 times negative 3 plus y equals 6. Okay, well, negative 4 times a negative 3 will give me a positive 12, right? Negative times a negative is a positive, and 4 times 3 is 12. So now we have 12 plus y equals 6, right? I want to get that y all by itself, so I'm going to subtract 12 on both sides, and so I get y equals negative 6. Okay, and so now I have an answer of x equals negative 3 and y equals negative 6. And my last step is just to check that those answers work in both original equations. Okay, so x equals negative 3, y equals negative 6. I'm going to check that in each of them. So negative 4x plus y equals 6. Negative 4 times negative 3 plus a negative 6. Does that equal 6? That's my question, right? So negative 4 times negative 3, again, is a positive 12 plus a negative 6. Does that equal 6? Well, that's just saying 12 plus a negative 6 is the same as saying 12 minus 6. And yes, 12 minus 6 is 6. So 6 equals 6. So it works in my first equation. And I'm just going to check it in my next equation. So negative 5x minus y equals 21. Okay. Negative 5 times negative 3 minus a negative 6. Does that equal 21? Okay. Again, negative 5 times negative 3. Negative times the negative is a positive. So we have 15. And then negative minus a negative 6 means that we're going to do plus a positive 6. And does that equal 21? Well, yeah, 15 plus 6 is 21. So 21 equals 21. Okay? So my solution set to this systems of equations is that when x equals negative 3 and y equals negative 6. Okay? So your solution is the point negative 3, negative 6. Okay? You can think of it like that. All right. So now let's do another example, okay? One where maybe we have to multiply, okay? So I'm going to clear this board and start with a new one, okay? So let's look at this guy. Negative 3x minus 10y equals negative 4, and x minus 5y equals 18. Okay, so you can see here, right? None of my variables have the same coefficient in front of them, right? This has a negative 3, this has a positive 1. Right here we have negative 3, here this is a positive 1, right? Here this is negative 10, and this is a negative 5, okay? Well, I want to get these guys to be multiples of each other, and only one variable, right? So I can pick either your x or your y, right, to eliminate. So I'm going to start with the x. I'm going to try to eliminate my x. So how do I get what can I multiply 1x by to make it the opposite or the negative of negative 3x? Well, 1 times 3 would give me positive 3, right? So if I multiply this whole equation, right, by 3, I'm going to end up with a positive 3x here, which would eliminate when I add this variable, okay? So let's try that, right? And now why I say you have to multiply the whole equation by 3 is because we can't just change one part of your equation, right? What you do to one part of your equation in order to keep it to be the same equation, you have to do to all parts of your equation. Okay, so now we're going to end up with one new equation, right? But I'm going to rewrite them. So negative 3x minus 10y equals negative 4. And now this guy, right, I'm going to distribute this 3 to each part of this equation, right? So 3 times x is just 3x. 3 times negative 5 or minus is 15y, negative 15y or minus 15y. And then 3 times 8 is 54, okay? 3 times 18, I mean, is 54, right? 18 times 3. 3 times 8 is 24. 3 times 1 is 3. Plus 2 is 54. Okay? You can use your calculators also. That's fine. That's 18 times 3 is going to give you 54. Okay. Now I'm going to add these two equations because when I add these guys, right, these are going to eliminate. We're going to get rid of these, right? Okay, so negative 3x plus 3x, bye. You're gone. Now we have negative 10y plus a negative 15y. So that's going to be a negative 25y. Okay, and here we have negative 4 plus a 54, which means we're just going to have 50, right? Negative 4 plus 54 is going to give us 50. Okay, Now we want to solve for y, so we're going to divide by negative 25 on both sides, right? And so we get y equals negative 2. Okay, so that's our first part of our solution. We still have to find out what the x will equal. Okay, and so we're going to take one of our original equations. Again, it doesn't really matter which one you choose. I'm going to choose the x minus 5y equals 18, just because the x is already has a coefficient of 1, positive. I like all those things, so I'm just going to do that. I can show you it will not make a difference, whichever equation you choose. I just like to try to think of which one would be easiest to solve. Okay. So x minus 5 times negative 2, right? That's what our y was, equals 18, right? So x, negative 5 times a negative 2 is a positive 10 equals 18. So we have x plus 10 equals 18. We're going to subtract 10 on both sides. And so we get that x equals a positive 8. Okay. And again, we always want to check your answers. Okay. Oh, I did say I would show how it's going to be the same as the other one, right? So let's do that real quick. So negative 3x minus 10y equals negative 4, right? And I want to show that if I had done this as y equals negative 2, I could have also just solved for the x, right? So negative 3x minus 10 times negative 2 equals negative 4. So we have negative 3x, negative 10 times a negative 2 is plus 20 equals negative 4. So I'm going to, negative 3. I'm going to subtract 20 on both sides here. Okay. And so I end up with negative 3x is equal to negative 24. Divide by negative 3. Divide by negative 3, and I get that x equals 8, right? The same thing as I got when I used the other equation, right? And so try to think which one would be easiest to solve. You find your other variable, but if you don't, it doesn't really matter. You will get the same answer as long as you do your work correctly. Okay, now we're going to check. So negative 3x minus 10y equals negative 4. Our solution is 8, negative 2, right? So negative 3 times 8 minus 10 times negative 2. Does that equal negative 4? Well, let's check. Negative 3 times a positive 8 is going to be a negative 24. Negative 10 times a negative 2 is going to be a positive 20. And does that equal negative 4? Well, yeah, negative 24 plus 20 is negative 4. So negative 4 equals negative 4. Perfect. We got it. Now, again, we want to check the other equation. So our other original equation was x minus 5y equals 18. Okay, and so again, we're going to use our solution set. So we have 8 minus 5 times negative 2, and we're going to check if that equals 18. Now, negative 5 times a negative 2 is a positive 10. So 8 plus 10, does that equal 18? Well, yeah, 18 equals 18. Perfect. Okay, so this is solving systems of equations using the elimination method, right? Elimination method, again, we want to eliminate a variable, okay, by adding those two equations together. Okay. And that's pretty much that here. All right. So hopefully this helped. Bye.